In this video, I want to have a look at dependent and independent events in probability. So two events are independent if the outcome of one event doesn't affect the outcome of the other. So for example, if we had an experiment where we were flipping a coin and we were rolling a die, then the outcome of the roll of the die isn't at all affected by what happens when we flip that coin. They're two completely separate or independent things. Two events are dependent if the outcome of one event does affect the outcome of the other. So for example, if we were choosing a captain and a vice captain from a group of people, whoever we choose as captain is going to affect the probability of somebody else getting chosen as vice captain. So let's have a look at an example. So we've got a coin is tossed and a die is rolled. So as our example set up here, this is going to be these are going to be independent events. So we're asked to list the outcomes in the sample space. So we're going to do that up here. So in our sample space, we can either have heads or tails. Now you could just list these. I'm going to put them in a bit of a table to keep track of them. So we could have a heads and 1 or tails and 1. We could have heads and 2 or tails and 2 and all the way up to 6. Right, so that's our sample space. Question B asks us to find the probability of tossing a head. So out of our 12 possible outcomes, 6 of them have heads. So we could write it as 6 over 12. Or we could just write it as a half because half of them have heads. For part 2, it says the probability of rolling an even number. So that could be our 2s, our 4s, or our 6s. It doesn't matter whether it's heads or tails. So that's going to be 6 out of the 12 again, which will just give us a half. Now the probability of rolling a head and an even number, tossing a head and rolling an even number, that would only be the H2, the H4, and the H6. So that would be 3 out of 12 instead, which would simplify to 1/4. Now the next question says, is the probability of tossing a head and rolling an even number, that's what we just figured out was 1/4. It wants to know if that's equal to the probability of tossing a head and times the probability of rolling an even number. So we figured out this one was a half, and we figured out the probability of rolling an even number was a half as well. So if we multiply those two things together, we're going to get half times a half, which would give us 1/4. So the probability of tossing a head times the probability of rolling the even number gives us 1/4. And that is exactly what we got when we looked at the probability of tossing a head and rolling an even number. So that means that those two things are equivalent. And then it says, are the two events dependent or independent? And we already said those are independent because the result of the coin toss doesn't affect the roll of the die at all. All right, for our second example, we've got a bag that contains 3 blue marbles and 1 yellow marble. 2 marbles are drawn from the bag without replacing the marble from the first draw. So we're going to pull one out, and we're just going to set it aside and then draw a second one out. So it's not going back into the bag. Part A asks us to find the probability of selecting a blue marble on the first draw. So on the first draw, we've got 3 blue marbles and 1 yellow marble. So we've got 4 all up and 3 of them are blue. So we're just going to have a 3 in 4 chance of pulling out a blue marble. Part 2 says selecting a blue marble with the second draw if the first marble was blue. So we pulled out the blue marble from the bag and we put it aside. So that means that what's left in the bag is we're going to have 2 blue marbles and 1 yellow marble this time. So we're going to have a probability of pulling out a blue one of 2 out of 3. Because there's only 3 marbles left, we took one out, and because the one we took out was blue, we only have 2 left instead of 3. Then it says, are the two events dependent or independent? So in this case, they will be dependent. And it's because the probabilities change. So what we pull out in that first draw affects the probabilities in that second draw. So that's having a look at probabilities with dependent and independent events.